Okay, so welcome back to part 2 of our data mining series. In part 1, we explored the fundamental concepts and techniques of data mining, including classification, clustering, and association rule mining. We also introduced a case study on customer segmentation for retail. In today's session, we'll build upon those concepts by diving deeper into advanced techniques and real-world applications. So let's begin by revisiting our case study and walking through the detailed steps of applying data mining techniques in a business context. So here you'll see we'll be exploring advanced data mining techniques and their implementation within our case study on customer segmentation. These techniques go beyond the basic methods we covered in part 1 and offer powerful ways to extract more complex insights from data. So first of all we have text mining, which involves the process of extracting meaningful information from unstructured text data, such as customer reviews or social media comments. It's often used for sentiment analysis and keyword extraction. Next, we have web mining. This focuses on extracting useful information from web content, then structure and usage patterns. Companies often use web mining to analyze user behavior and optimize websites. Then we have time series analysis. This technique is used to analyze time ordered data, such as sales figures over a period, and it also helps identify trends, seasonal patterns, and anomalies over time. And finally, we have deep learning in data mining, which is an advanced subset of machine learning that uses neural networks to model complex patterns in large data sets. So in data mining, deep learning can be applied to tasks like image recognition, natural language processing, and predictive analytics. So each of these techniques has specific applications and benefits, and we will demonstrate how some of these methods can be implemented within the context of our retail case study. So here we'll just go deeper into text mining, which is the process of extracting meaningful information and insights from unstructured text data, as I said earlier. This is particularly useful in today's digital world, where vast amounts of information are available in text format from sources like emails, social media, reviews, and articles. Now, we have some use cases here. First, we have sentiment analysis. Now, understanding the emotional tone behind written content. This is called sentiment analysis. For example, businesses use sentiment analysis to gauge customer feelings from social media comments or product reviews. If someone comment something bad for a product, they can just try to analyze something emotional, like they try to get the emotional tone behind the written comment. So in that case, that will be a sentiment analysis. Next, we have document classification. So it automatically organizes large amounts of text into predefined categories. Um, this can be used in news aggregation, filtering spam emails, or classifying customer feedback. Then we have topic modeling and summarization. It identify key themes in large text documents and generating concise summaries. Now we'll see what techniques we can use. So first of all, we can use natural language processing, NLP. This is the cornerstone of text mining, which enables computers to understand, interpret, and respond to human language. It involves tasks like tokenization, TF-IDF, named entity recognition. These are the tasks in which is inside the natural language processing. So first of all, tokenization is like breaking down text into smaller units such as words or phrases. So here we can use tokenization to process the language by breaking down the text into smaller units. Then we have TF-IDF, which means term frequency inverse document frequency. So it is a method to evaluate how important a word is in a document relative to a collection of documents. Means like if you have a collection of documents and if you have a word which is more important than the entire collection, or in a document relative to a collection, then it evaluates the importance of the word. So next we have named entity recognition. So identifying and categorizing key entities like people, places, organization, which is mentioned in the text. So we can recognize those words or like entities for natural, and then use it for our natural language processing. So these three are included inside the natural language processing technique. Then we have what kind of tools we can use. Python, which is a programming language, and libraries like NLTK, which means Natural Language Toolkit, and Sparse CI. We can use those libraries to program, to process the to do the processing of the language, and it is widely used for natural language processing and text mining tasks. Then we can have RapidMiner and SAS Text Miner. These are commercial tools that offer built-in functionalities for text mining. So businesses sometimes use those commercial tools. They have to buy these because not everyone is a programmer, and if you have already built-in functionalities, it makes your work easier, and it like you can reduce the amount of time spent on this activity or this task. So businesses who have a really big data and who have a really big processing task, they can use commercial licenses and this kind of tools to reduce the time and use the built-in functionalities. So basically it is text mining is essential for analyzing large amounts of textual data efficiently and making it possible to derive actionable insights that can inform business strategies, improve customer service, or track brand sentiment. Next, we have web mining, which is the process of analyzing web data to extract useful patterns and insights. Given the vast amount of information available on the web mining is essential for understanding user behavior, web structure, and content trends. So we have three primary types of web mining: web content mining, structure mining, and usage mining. So first we'll see content mining. This involves extracting information or useful information from the content of a web page or web pages, such as text, images, or videos. It is often used to gather data from websites to support content analysis, summarization, or even product recommendations. Next, we have web structure mining. This focuses on analyzing the structure of websites, particularly the links between web pages, and it helps in understanding the relationships between different websites. The importance of specific pages, for example, through algorithms like PageRank, and how content is interconnected. Third, we have usage mining. This type of mining involves analyzing user behavior, and it tracks web users patterns such as click stream data, session logs, and user interactions on a website. Web usage mining is crucial for understanding how visitors navigate a website and can inform website optimization and user experience improvement. Then you'll see some use cases. So personalized recommendation. So web mining is used by e-commerce websites basically to track users' browsing and purchasing history to generate personalized product recommendation. So the best example is whatever you will search on Google, you will get an ad on Facebook or Instagram right away, and whatever you are saying, your phone is listening to you, and you will get an ad related to that particular thing you are talking about. So this is basically the use cases what websites are doing. It is getting whatever you're searching, whatever you're writing, whatever you're doing in any platform, the other platforms will get your data, and then it will show you the personalized product recommendations. Then second is web traffic analysis. So by analyzing web usage data, businesses can track the effectiveness of marketing campaigns, identify bottlenecks in website navigation, and improve overall website performance. Now, through web mining, organizations can harness valuable insights from web data, allowing them to offer tailored experience and improve website architecture, and they can drive business growth. Okay, so next let's look at time series analysis. So it is a technique used to analyze data points that are collected or recorded at specific time intervals. This method helps in identifying trends, seasonal patterns, and other characteristics of data that changes over time, making it invaluable for forecasting and predictive analytics. So we will see some techniques here. First is ARIMA, which means auto-regressive integrated moving average. This is a popular forecasting technique used for analyzing time series data. ARIMA combines auto-regressive and moving average components to predict future data points. Next, we have exponential smoothing. This technique is used to smooth out data by giving more weight to recent observations, making it particularly useful for short-term forecasting. Next, we have seasonal decomposition. This method helps break down a time series into its trend, seasonal and residual components, allowing analysts to understand recurring patterns and long-term trends. Now we can have forecasting cells and stock market analysis, these two types of use cases. Now, businesses use time series analysis to predict future sales based on historical data, helping in inventory management, budgeting, and goal setting. Then, second, we have investors and financial analysts rely on time series. Okay, so deep learning is an advanced technique in data mining that uses neural networks with multiple layers to model complex patterns in large data sets. Unlike traditional machine learning algorithms, deep learning models can automatically discover patterns and representations from raw data without the need for manual feature extraction. So these are the techniques we can use. First is convolutional neural networks, CNNs. So CNNs are primarily used for image related tasks. They process data in layers where each layer extracts different features of the input data, such as edges or textures, making them particularly useful for image recognition. Next, we have recurrent neural networks, RNNs. So RNNs are designed to handle sequential data such as time series or natural language. It also have loops in their architectures, allowing them to maintain a memory of previous inputs, which makes them effective for tasks involving sequences or time-dependent data. Then we have some use cases. First is image recognition. Deep learning has revolutionized the field of computer vision, enabling systems to accurately recognize objects, faces, and even emotions in images. So if you think about a software or something that helps to find or detect faces and some objects or emotions, like some softwares if you smile, it will identify that you're smiling, your emotion is smiley, and then if you're angry, it will say you're angry. So these are the things like objects, faces, and even emotions in images, which are recognized by those softwares, where we use deep learning neural networks. Next, we have natural language processing. In NLP, deep learning models are used for tasks like language translation, then sentiment analysis and text generation, as we already saw some examples or techniques in our previous slides, the ability of deep learning models to process and understand the structure of language has led to significant advances in areas such as chatbots and virtual assistants. If you think about Alexa, that is a virtual assistant. If you think about Siri, that is also a virtual assistant, and every website or every site has a chatbots nowadays. When you will need some help, you will open the chatbot, and then you will get all the answers which is frequently asked, so that it reduces the time. If a man or if a real person has to answer same question every time, that will take a lot of time. So they made some chatbots that can answer some frequently asked questions to save times, and then if it doesn't solve your problem, you can contact a real person for further information. So these are the systems or chatbots and virtual assistants nowadays we are seeing. We all knows about those chatbots and virtual assistant. We most of us knows about Siri and Alexa, because Alexa is virtual assistant, is a system from Amazon. So I hope most of us already know about those virtual assistants. Now, deep learning's ability to model complex nonlinear relationships in data has made it a critical tool to domains where traditional machine learning techniques may fall short. Okay, so here we'll see so data mining becomes increasingly complex when applied to big data due to the vast amount of information generated every second. There are some challenges in big data environments. So we'll see some challenges, some key challenges here. First, we have volume, velocity, variety. Big data is characterized by its massive size, which means volume. So the volume is very big, the size. The speed at which data is generated, which is velocity, and the different types of data, which is variety, such as structured, unstructured, and semi-structured data. Next challenge is scalability and processing power. So traditional data mining techniques may struggle with the processing power needed to handle the sheer volume of big data. It requires scalable solutions to process and analyze these large data sets efficiently. Now, there are some solutions. So first is distributed computing, like Hadoop or Spark. To address these challenges we just saw, distributed computing platforms like Hadoop and Spark have been developed. These platforms allow for parallel processing across multiple nodes, which enables the analysis of large datasets more efficiently. Hadoop's HDFS, Hadoop Distributed File System, which stores big data, while Spark's in-memory processing capabilities make it faster for real-time analysis. So one is useful for storing big data, and another one is useful or good for in-memory processing capabilities, like it is more faster for real-time analysis. Then second is real-time data mining techniques. Like in big data environments, it's important to process and analyze data as it is generated. So because data is generated every second, so you have to get those data and process in real time. So real-time data mining techniques help businesses respond quickly to trends. Like I said, you just googled something, you just googled about new iPhone, and then next second when you open your Facebook and Instagram, you will get an ad about new iPhone. So that's how real-time data mining techniques help businesses to respond quickly to trends, anomalies, or opportunities. So they get the opportunity to give you personalized ad just in real time, as quickly as possible. So where we need the data mining techniques, these techniques involves stream processing, where systems can continuously process and analyze data in real time. It will be helpful if we get a big data ecosystem diagram, but I will provide this visualization, an image of this ecosystem diagram. I forgot to add it here, so I will also include this on Moodle. To understand the complexities of big data, it's helpful to visualize the ecosystem. So it can show the various components involved, such as data sources, processing frameworks like Hadoop or Spark, and analytical tools. So I will provide this diagram, so that will be helpful. Okay, so next we have in this section we'll walk through the detailed steps involved in our case study on customer segmentation for retail using the CRISP-DM cross-industry standard process for data mining framework. This approach ensures a structured methodology for conducting data mining projects. So here is the breakdown of each section. We'll see business understanding. This is the first step, which is to understand the business problem. In this case, the objective is to segment customers based on their purchasing behaviors to enable targeted marketing strategies. We need to define clear business goals to ensure the analysis meets the company's need. Next is data understanding. After identifying the business objects, the next step is to gather and explore the data. This includes customer demographics, purchase history, and transaction data. In this phase, we examine the data to assess its quality, identify patterns, and understand its structure. Next, we'll do data preparation, which involves cleaning, transforming, and organizing the data so that it's ready for modeling. Then fourth, we'll do modeling. We apply clustering algorithms such as K-means to group customers based on their purchasing power or purchasing patterns. We may also use classification techniques like decision trees to predict which segment new customers belong to based on specific features. Next, we have evaluation. So after building the models, we will evaluate their performance. This involves assessing the accuracy and effectiveness of the customer segments created and ensuring that the results align with the business goals defined earlier. So finally, the results are deployed into the business environment. This could involve implementing the segmentation in marketing campaigns or incorporating the insights into decision-making processes. So this structured walkthrough ensures that the case study is tackled methodically, leading to actionable insights that align with business objectives. Okay, so we'll see more deeper here. So first we'll see some objectives like improve targeted marketing strategies. By segmenting customers based on their purchasing behaviors, the business can create tailored marketing campaigns that better resonate with different customer groups. And then increase customer retention. Understanding customer segments also allows the business to identify high value customers and implement retention strategies that cater to their needs, which increase overall customer loyalty. To achieve these objectives, the following business questions need to be addressed. So, first question is, who are our key customer segments? And then, what are their purchasing behaviors? So, first one is identifying the main customer groups, which is critical for designing targeted strategies. And the second one's answer is by understanding how different customer segments behave, such as their buying patterns, frequency, and preferences, the business can optimize product offerings, promotions, and personalized experiences. So, answering these questions sets the foundation for the data mining process and ensures that the results are actionable and aligned with business goal. Next is data understanding. So, in this case study, the primary data sources include customer demographics like information such as age, gender, income, and location, transaction records like data on customer purchases, including what products were bought, how often, and at what price. Then, website interaction, which is behavioral data from customer interaction with the company's website, such as clicks, time spent, and products viewed. Now we'll see exploratory data analysis, EDA, where we have summary statistics, which involves calculating key metrics such as mean, median, mode, and standard deviations to get an initial understanding of the data's distribution and characteristics. Next, we have data visualization, and we can visualize the data through histograms, scatter plots, and other graphical representations, which helps reveal patterns and relationships in the data, as we already know about those visualization techniques and how we can do that. These visualizations make it easier to identify trends, outlier, and correlations between variables. So the purpose of this phase is to familiarize ourselves with the dataset and ensure that it aligns with the business goals established earlier. It also helps in identifying data quality issues that may need to be addressed before moving on the next step. On this step, we'll do some preparation for data. We'll prepare the data. Basically, this is the step where we prepare the data for modeling. Now first we'll do data cleaning. So we'll try to handle missing values and outliers. This can involve strategies such as filling in missing data using statistical methods, mean or median imputation, or removing records that contain too many missing values, outliers, or extreme values that don't fit the general pattern of the data, um, which may also need to be removed or treated to prevent them from skewing the results. So that's how we can do the data cleaning. Next we can do feature selection. So not all data points will be relevant to the analysis. In this step, we identify and select the most relevant features that have the strongest impact on the business problem. This helps improve model performance and reduces computational complexity by focusing only on the most important variables. Next, we have data transformation. So this step involves normalizing the data, like scaling numerical values to a common range and encoding categorical variables, like converting text-based data into numerical formats so that algorithms can process it. And so, for example, customer categories like gold or silver might be converted to numerical values like 1 or 2 so that the algorithms can easily process it. Tools we can use Python or R. Both are robust functionalities for cleaning, transforming, and preparing datasets for analysis. So next we'll do modeling. Now here we will apply the data mining techniques to the prepared data. This is where we use algorithms to uncover patterns and relationships that can help segment customers effectively. The choice of algorithms depends on the type of problem we're solving. So first, the techniques we can apply is clustering, k-means or hierarchical, and then classification like decision trees. Then for the parameters we have to choose the number of clusters. For k-means clustering, one of the critical parameters is determining the optimal number of clusters k. This can be done using methods like the elbow method, which helps find the number of clusters where adding more does not significantly improve model performance. Then evaluation metrics. Once the models are built, it's important to evaluate their effectiveness. For clustering, this could involve metrics like the Silhouette score or within cluster sum of squares. For classification, common metrics include accuracy, precision, recall, and the F1 score. So once the models have been built, it's important to evaluate their performance to ensure they meet the business objectives and produce reliable results. So the metrics we can use Silhouette score for clustering. This metric helps measure the quality of the clusters created. This method evaluates how close each point in a cluster is to points in the neighboring cluster. So and scores ranges from -1 to 1, where a higher score indicates that the clusters are well separated and distinct. Then we can use another metric is accuracy, precision, recall for classification. So for accuracy, we can measure the percentage of correctly classified instances out of the total number of instances. Then for precision, and we can measure the proportion of true positive predictions among all positive predictions. It helps determine how accurate the positive predictions are. Then for recall, we can measure the proportion of true positive predictions among all actual positives. It helps determine how well the model identifies positive instances. Now, to validate we have validation techniques um, to validate those answers. So first is cross validation, which involves splitting the dataset into multiple subsets and training the model on different subsets while testing it on the remaining ones. Cross validation ensures the model performs well across various portions of the data and avoids overfitting. Next, we have train test split. In this technique, the data is divided into two sets, the training set and the test set. The model is trained on the training set and then evaluated on the test set to gauge its performance on unseen data. So these metrics and validation techniques ensure that the models are accurate and generalize well to new data, helping the business making reliable decisions. So, when working with data mining, it's essential to follow industry based practices and uphold ethical standards to ensure the effectiveness and integrity of the models. So here are some best practices we can do. We can have data quality management. So this is similar to what we learned on data analytics. So first, which you can ensure high quality data, which is critical for the success of any data mining project, because if your data is not correct, you will not get the right result. Then choosing appropriate techniques. So these are the same things I'm repeating we did for analytics, because data analytics is basically what data mining is doing. We are using data mining techniques to analyze the data. So we'll have same things here. Continuous model evolution. What I just said, that we're getting new data every second. So whatever techniques or process you're using, it should be continuous, and you have to evaluate your model continuously so that it will be updated over time. Then there are some ethical considerations for data privacy and security. Like businesses are getting your personal data to give you personalized experience or promotional ads. They're getting your personal data, so which is very sensitive for any customer, and it is important to adhere to data privacy laws and regulations. Safeguarding personal information and ensuring secure storage and processing of data is paramount to maintain customer trust. And then we have avoiding bias in models. So you have to be biased for so you cannot be biased. It's crucial to ensure that models are not biased against any group based on race, gender, age, or other factors. Then transparency and explainability. Models should be transparent and explainable to stakeholders. This is particularly important when making data-driven decisions that affect customers or the businesses. So here are some future trends. As technology advances, we'll have several emerging trends that are set to reshape how businesses and industries leverage data for decision making. First is data in artificial intelligence and machine learning, which is a very popular topic now. Data mining is becoming increasingly integrated with AI and machine learning techniques, allowing for more sophisticated models that can learn from data and improve over time. This integration enhances the ability to predict outcomes, automate processes, and uncover deeper insights from complex data sets. Then we have real-time data mining. The demand for real-time insights is growing across industries, because if like you're searching something on Google and some other company get and process your data more quickly than the other one, so you have to be competitive and you have to process as quickly as possible to give you the product promotion ad. So real-time data mining is very important nowadays to compete with your competitors. That let's say we are searching something on Google. You search something like for some Adidas sneakers. Let's say you search for some Adidas shoe. Then the Adidas shoe website processed your data more slow than Amazon. So Amazon processed your data more quickly than the Adidas website. And Amazon, when you're opening your Facebook or Instagram, you're getting an ad from Amazon about the Adidas shoe, not from the Adidas website itself. So you are basically going to buy the shoe from Amazon most of the time. Or if you're getting this, so you have to be competitive all the time. And let's say same thing, you are buying from Amazon and you're getting ad from Temu as well. If you don't know about Temu is a Chinese online platform which are popular now these days. They are selling the same product Amazon have, but in 4 times cheaper price, as it's coming from China. Those products which comes from China is basically low cost, and they have low cost products. So we're getting the same product from China in low cost. And if you get the ad before Amazon, if you get the ad from Temu before Amazon, you probably buy this from Temu. So Amazon lost the market. So this is how it works. So if you have to be competitive, if you need to get customers, you have to be on real-time data mining techniques. Then third one is automated data mining. These platforms are becoming more popular nowadays. It allowing non-experts to build sophisticated models with minimal human intervention. Intervention. So AutoML automates the end-to-end process to applying machine learning to real-world problems, from data preparation to model selection and tuning, making data mining more accessible. Now, what are the impact on industry? With the advancements in AI, ML, and real-time processing, businesses can build more accurate and powerful predictive models, which enhance the predictive capabilities. Then the rise of AutoML and user-friendly data mining tools means that mining is no longer limited to experts. So we have greater accessibility for non-experts also. So these trends are making data mining more efficient, powerful, and accessible, helping businesses unlock even greater value from their data in the years to come. Okay, so here are some related resources. I also added those on part 1 slide. After all these data mining techniques and all these tools, if you don't understand anything or any sites or any technique, just let me know. You can email me anytime. So that's all for today, and let me know if you have any question. Thank you.